everybody. Welcome to week 4 of the Hazardous Materials Safety Officer program, the final week, and we're beginning to wrap things up. This week, we're going to discuss implementing that planned response, getting those people downrange safely, and making sure that the site safety and control plan in the hot and warm zones of operations are maintained properly. We're going to evaluate the progress through the entry. And then once the entry is completed, we're going to discuss those things that we're going to use to terminate the incident appropriately. In order to accomplish this, our objective is going to be to identify how the Hazardous Materials Safety Officer can assist the hazmat group supervisor or branch director in the implementation of the site safety control plan in the hot and warm zones of operation. Remember, the hot and warm zones are where the hazmat safety officer is ultimately responsible for. In order to do that, we're going to identify the duties of the HMSO during the implementation of the response plan. We're going to identify the contents of a safety briefing and who is responsible for doing that safety briefing. We're going to discuss the monitoring activities that the hazmat safety officer is going to use to monitor the operations and ensure that the site safety control plan is followed. We're going to identify communications considerations, and we're going to talk about taking corrective actions for those situations that require it. So the duties of the hazmat safety officer is obviously monitoring the safety of the personnel, and that is within the hot and warm zones of operation. So they're going to be wanting to evaluate all things going on within the purview of the hazmat group area. We're going to be conducting safety briefings, or at least ensuring that those safety briefings are conducted appropriately. We're going to implement and enforce the site safety and control plan in the areas of operation. We're going to maintain the necessary communications. We're going to monitor the status of things going on, both within the entire command structure and within the hazmat group, because the safety officer needs to know if there's something going on outside the hazmat group's area of responsibility that could impact their operations. And then we want to look for any deviations from the site safety and control plan and make sure that we take appropriate corrective measures. Medical monitoring is obviously one of the first things that comes into play. But obviously, there is a standard of care that says that prior to entry, medical monitoring will occur for the personnel wearing chemical protective clothing. Now, your organization's policy concerning medical monitoring and your emergency response plan prevails. We aren't here to dictate what is appropriate medical monitoring for you. I think everybody has a pretty good idea of what needs to be done. But remember one thing. Pre-entry vitals are not really indicative of anything that is going to happen that is bad. The only time that we can identify things that may happen based upon pre-entry vitals is to make sure that the people that are engaged in hazmat response are in an effective medical surveillance program. And this has been the standard since 1989 when the regulations first came out. All hazmat team members or all personnel assigned specifically to hazmat duty shall be involved in a medical surveillance program that includes a baseline, an annual physical, and then a termination exam. And we all know that to be true. What happened in the early days of hazmat, though, was that many organizations did not have the funds allocated to do those baselines and annual medical examinations. So what happened was a de facto standard of care started to develop where organizations said, well, we'll get a set of pre-entry vitals and we'll call that the baseline. And then we will get exit vitals and we'll call that the termination. And it really became a de facto standard of care. There's no regulation that says you must do pre-entry vitals prior to entry. However, it has become a de facto standard of care, and it is recognized by NFPA that that is what we should be doing. And obviously, when we have the time, we need to do that. However, if we select the proper administrative, engineering, and PPE controls to protect our responders, if we're managing our scene appropriately, what is the greatest risk? The greatest risk to our personnel, as we've discussed before, is heat stress. And therefore, looking for heat stress becomes our greatest concern. And where are vitals most indicative of that problem? Most indicatively, though, the vitals taken post-entry are most indicative of a heat stress situation. Now, that's not to say pre-entry vitals are not indicated. We always want to try to get a blood pressure, a pulse, respiratory status, whatever your organization's standard operating procedures call for in the pre-entry setting. But where those vitals really, really count is in the rehab function or the post-entry environment. What we're looking for is we're looking for those vital signs to return to normal. Now, if heat stress is the greatest risk that we're encountering, again, we've selected the right administrative controls, engineering controls, and PPE, so heat stress is what's going to be the problem. The number one vital sign for indication of heat stress is pulse rate. There are two reasons pulse rate will not drop during rehab. One, dehydration. And we always try to address that as much as we can. We try to hydrate pre-entry and post-entry as much as we can. The second reason pulse rate will not come down is increased body core temperature. And it's important that we address body core temperature and make sure that we are not allowing people to overheat or maintain a high body core temperature. And we talked about some of those things that we can do to lower body core temperature in our previous unit. The contributors to heat stress, there are 5 or 6 contributors at the hazmat incident that are going to drive this heat stress. Number one is activity levels. How hard are they going to work? How long are they going to be in the personal protective equipment? What are the environmental considerations? Are they properly hydrated? What level or type of PPE are they wearing? Are they wearing structural firefighter protective clothing that allows some heat dissipation, or are they in that plastic bag or barrier garment, for a better term, of level B, even level C, or level A PPE, which is creating that high humidity environment that we talked about in the last unit? And mostly, what is their level of physical fitness? Are they acclimated to this? Do we have them in a good physical fitness program? Are we medically monitoring them appropriately? Calculating the work mission duration, there's a model from the National Fire Academy on calculating the work mission duration from their operating site practices class that suggests that we take 20% right off the top of our 60-minute SCBA time as a safety measure. Then we do our round-trip travel time down and back to the scene. Let's say that's 3 minutes each way. If it takes us 10 minutes to decontaminate somebody, we need to take that 10 minutes off. Then if the environment, depending upon the temperature environment in the environment, we are going to take either 5 or 10 minutes off of that. And depending upon the level of workload, we're either going to take 5 or 10 minutes potentially off of that. So on a 60-minute model, we're typically looking at a work mission duration of about 22 minutes. Now, differences in environment, differences in workload, all those things can change your work mission duration, but this is a good basic formula for calculating how long we're going to allow people to work downrange. Once we've got this all figured out and we've got our site safety and control plan developed and the incident action plan has been identified, then it's time to get people ready to go downrange. And that means that now it's time to do that pre-entry safety briefing. Now, who does that? In your organization, it may differ. It may be the entry supervisor, it may be the hazmat group leader, but the safety officer has to be present to make sure all the components of the site safety and control plan are addressed. What are we going to brief them on? The best way to do this briefing is to go right down that site safety control plan. Use that ICS 208HM because it has everything in there that needs to be discussed. It has your personal protection, it has your chain of command, it has the anticipated hazards, it's got action levels, it's got decontamination, it's got your entry objectives, and it's got your emergency procedures. Those are all the things that need to be discussed in the pre-entry safety briefing. Where's it going to be conducted? There's actually 2 places a safety briefing can be conducted. The one that we typically consider is that pre-entry briefing that's done in the dress-out area once everybody's dressed to the waist and ready to go. That's the pre-entry. But there could also be a safety briefing in the staging area of the incident when responders check in. And there may be a safety briefing that is also conducted there as additional responders are arriving at the scene. But we're typically focusing on that pre-entry safety briefing. Contents of the safety briefing, like I said, typically it follows that ICS 208HM. That's why we really believe in that or a similar document that has all those components in there. We're going to talk about the hazards analysis, the product, the container, the environment, and cause. We're going to let people know what we think they're up against. The protective actions, what engineering, what administrative, what PPE controls are in place to protect them. What are our monitoring, our air monitoring and action levels? When we send people downrange with air monitoring instruments, they should have defined action levels, such as 10% of the LEL is a turnback, or 2 millirem an hour is established the hot zone in a radiation incident. Those types of action levels need to be defined either by policy or specifically for the particular incident. What decontamination procedures are going to be used? Is this going to be a quick flush with water because it's a highly water-soluble material like anhydrous ammonia? What are our communications? Who's on what channel? What are our backup communications look like? And we'll talk about communications in just a couple minutes. The medical plan, entry objectives and safety procedures. What are they expected to do? What safety procedures should they follow? And should an emergency occur, what are those emergency actions? And typically those are defined by policy, such as your emergency alerting devices and where people are to go in the event of an emergency and what action should automatically be taken. That should be a policy in place as to emergency procedures on scene of a hazmat incident. Once we get them briefed and we send them downrange, then we begin to implement and enforce that site safety and control plan. We make sure that our control zones are established and marked even before they go downrange. That should already be in place. We should identify a safe refuge area. If something were to go wrong, can the emergency responders or the personnel downrange get to an area of safe refuge until we're prepared to deal with them? Actually, we should be prepared to deal with them anyway. But there should be an emergency or safe refuge area identified for everybody working on the scene so that if something happens, where is that rally point that they are going to stand by at until they can be dealt with? What medical monitoring is being done? Has the PPE for entry, backup, and decon all been properly identified? And there's 3 things that we want to, as a safety officer, evaluate for. One, first of all, is it appropriate? Is the garment that we selected chemically compatible, obviously, with the material? Is it appropriate level? Number 2 is, has it been examined prior to donning? Let me tell you a little story. We had an anhydrous ammonia leak years ago, and it was a fairly significant leak. The anhydrous ammonia pump room and containment vessel were inside a small exterior building. So we were going to be putting people into that building, that small exterior building, in level A PPE to shut down the king valve on the system and shut down the system in accordance with the recommendations of the facility management. As the team was getting dressed, we had a process where your buddy checked your suit as the very last thing before you go downrange. You got to trust your partner. So you do a partner check, you make sure the zipper is closed all the way, and you have the person turn around and you just look at the suit just as a last-ditch examination. In fact, before you don it, before anybody dons it, they should be examining the suit and making sure that there's no signs of degradation or tears or any physical imperfections in the garment. But in this very last check, just before they started to go downrange, his buddy looked underneath the hood where the exhaust valve was, and the flapper valve in the exhaust valve was missing. This was one of those BFOs. This was one of those blinding flash of the obvious that we had a gap, that when people were testing the suit, there was not a checklist to make sure, absolutely sure, that that flapper valve and that one-way exhaust valve was put back in, and it got missed. This person would have gone downrange in a garment with no exhaust valve, and anhydrous ammonia would have gotten in the suit with him, without a doubt. It would have gotten in the suit. The first time he bent over and stood back up, the negative pressure in that suit would have sucked anhydrous ammonia right into that garment with him. That was the BFO. That was what we like to call the come to Jesus moment, that we need to do something. Before they don these garments, they need to lay them out, they need to look at them, they need to do a physical inspection of that garment prior to donning, and then they need to properly don the garment, and in decon, they need to properly doff it. The other thing with the Site Safety Control Plan, are all members, do they all have an assignment? Do they know what they're doing? Do we have a backup team that's ready to go for immediate deployment? And do they have the proper teams? Do you have a policy in place that says this is what the backup team's going to be ready to do? And in reality, the backup team's got to be ready to pull somebody in chemical protective clothing out. And I think we've all pretty much come to the realization that probably the best tool to have to do that is going to be a sked, and then any other tools based upon the observation of the scene. Have we determined what the work mission duration is? Go back to that calculation form. Do we have accountability and tracking? Are we tracking people going in and their air pressures and times? Who is doing that? Is that the safety officer typically? Is it the access control officer? Is it the entry supervisor? Whoever is tracking that accountability and those times needs to be consistent. And is decontamination in place and ready? Everything coming out of the isolation area needs to be decontaminated, or at least evaluated for the need for decontamination, because it's the safety officer's responsibility to ensure the prevention of secondary contamination. That's one of the major functions of the hazmat safety officer, is to ensure that we prevent secondary contamination. And we learned our lesson back in 2014 with the Ebola event. We learned that we had gotten laxed in decontamination, and that came back to haunt us in the Ebola event and other events that we've had since then with regards to decontamination. We've got to be much more effective at decon. There are 4 requirements to prevent secondary contamination. 4 things that the safety officer needs to make sure are in place to prevent that secondary contamination. Number 1, have we got good control zones established, and are they being enforced? And that is the role, that enforcement of those control zones is the site access control officer. But obviously the safety officer needs to make sure that that's happening. We need to prevent people and equipment, or ensure that people and equipment are decontaminated when exiting the hot zone. So there needs to be some observation to make sure that this is being done correctly. The people we put into decontamination to perform decontamination need to be properly trained, and those people also need to be properly protected. So 4 things: control zones, everything gets decontaminated, we make sure our personnel are properly trained, and we make sure our personnel are properly protected to do that decontamination. Communications and monitoring. Well, communication systems for hazmat obviously are unique. We obviously, we all know that entry should be on a separate channel from everything else going on. Ideally, we'd like to have them in some sort of in-suit radio comm systems. These don't have to be super complicated systems. In fact, I sort of like keep it simple, stupid. The simpler, the better. There is we will upload a study. It's called a SAVER study, where they evaluated in-suit radio communications equipment. And what was funny is one of the cheapest, I don't want to say cheapest, one of the least expensive or least costly system floated right up to the top because it was so simple and simplistic in operation. And we'll post that study for you in the optional review materials down at the bottom. If we don't have in-suit comms, then handheld portables might be our only exception. We also need to have emergency signaling devices or an emergency signaling policy in place, be that air horn blast, in combination with radio transmissions, but some form of emergency signaling. And we need to make sure that our people know how to use hand signals. There's going to be times where comms failures are going to occur, or there's going to be high noise situations where communications is going to be bad, and we may have to revert back to hand signals. We need to train our people in hand signals again and make sure that they're proficient in the use of hand signals. And the safety officer needs to understand those as well. The safety officer needs to monitor all communications. Now, not just the entry communications and the hazmat group communications, but needs to monitor all the communications going on scene, because anything going on in a support area that impacts the safety in the hazmat groups or hazmat branch area needs to be identified. We also need to expect regular communications from the entry teams. If we don't hear from them for a few minutes, we need to check with them. If at any time we're in out of line of sight operations and we do not have good comms in place, we've got to use a spotter. If they're going in the door at the warehouse and we lose communications, there needs to be a spotter at that doorway that we can see from the outside and they can be seen from the inside to ensure that backup communications. You know, think about it. Any post-incident analysis, any incident critique that you've gone to, you've probably always heard the problem with the incident was communications. If it's predictable, it's preventable. We need to know that if comms are one of those things that fails regularly, we need to be prepared with backups or even multiple redundancies to make sure that we can get messages out. Hand signals, it's a necessary backup. We need to make sure our people know the basic hand signals that they need to use. We need to go back to the basics. Okay, so we send our people downrange. They do their job. We're going to talk about monitoring the progress here in just a minute. But the other thing that the safety officer, hazmat safety officer, is responsible for is making sure that that post-exposure medical monitoring occurs. And by definition, post-exposure medical monitoring is required for any unprotected exposure over the OSHA permissible exposure limit. So if any of our personnel, be it the first responders that arrived on scene or be it the hazmat technicians, if something happens where they are exposed over the permissible exposure limit in an unprotected mode, then they need to be medically evaluated. Now, a real good guide to provide your physician and your safety officer with is what is called the biological exposure indices that's published by the American Conference of Governmental Industrial Hygienists. The TLVs we know are time-weighted average exposure limits that are published by ACGIH, but the biological exposure indices in that booklet give some recommendations on if you are exposed to this chemical or family of chemical, this is the type of test that should be performed. And it's a good guide for you to provide your physician and for the safety officer to have to ensure that the exposure monitoring occurs that's necessary to occur. Obviously, we defer to the physician who has knowledge in occupational medicine and toxicology to help identify this, but this is a good guideline for you to have, for your risk managers to have, for your physicians to have available to them if necessary. I recommend downloading it. You can get it at or buying it. You can get it at ACGIH. By the way, anything I recommend here, I have no vested interest. We have no vested interest in the purchase of it. It is a good handbook that comes out every year. Okay, now once we send them downrange, once that entry goes downrange, then we need to evaluate the progress while those people are downrange and what's going on to make sure that things are going the way we want it to go. So in evaluating the progress and evaluating how the plan is going once we've implemented it, there are three things we really want to look out for. One, we want to identify any deviations from the Site Safety and Control Plan or other standard operating procedures or laws and regulations that we're aware of, both in the hot and warm zone of operations. We need to make sure that there's no deviations, that this plan stays in place, that our organizational standard operating procedures stay in place, and so forth. And if we do identify deviations, we need to look at what the impacts of those deviations are and look at possibly taking corrective actions. We also want to identify high-risk, dangerous conditions that develop. things that we didn't plan for, those bolts out of the blue that can endanger personnel in the hot and warm zones of operation. We also want to monitor for the signs and symptoms of physiological or physical stresses to our personnel. This is a walk-around job, obviously remaining within the appropriate control zones, but the hazmat safety officer needs to have eyes on, as much as feasible, all of the operations within the hot and warm zone of operation. This isn't something that the hazmat safety officer sits in a command area and doesn't keep an eye on things. This is a hands-on, walk-around, management by walking around type job. Now, with regards to those identifying high risk and dangerous conditions that might develop, some of the things some of those possible situational changes obviously include things like an unexpected fire or explosion. Detection action levels are met. If the entry team using detection equipment indicates that some of these action levels have been met, that means that the situation is changing and it's not what we expect, and so therefore there may be a need to suspend, alter, or terminate operations. Container failures, sudden weather changes, incoming weather, PPE failures, personal injury. If we get updated information about the material or the conditions that change the hazard analysis and risk assessment, may require corrective action, or any support zone function that becomes compromised. If something in the support zone becomes compromised, it no longer allows the personnel to work safely, then corrective action is going to need to be taken. And those corrective actions can take the form of either suspending the operation, altering it, or terminating it. And when we suspend, alter, or terminate the action, we need to immediately communicate that change to the incident safety officer or the incident commander, the hazmat group leader, and obviously the entry team needs to know about that change. Now, suspending and altering are our preferred methods of operation, if at all possible. If we can just hold off on doing something until something has changed, sort of suspend it, put it on hold briefly while decon gets ready or something else catches up, that would be preferred. Altering it, changing the plan on the fly may be necessary. We want to try to avoid terminating unless it is obviously a very high-risk situation that we need to stop. When we terminate an action, we impede the ability to complete the incident action plan. So termination should be used when necessary, but not used unnecessarily. Do a risk-benefit assessment and determine whether or not immediate termination is required, or can we suspend or alter in some way to allow the incident action plan to go forward. So your main roles, again, is to identify deviations from the site safety and control plan and other standards. We want to identify those high-risk or dangerous situations that might develop that endanger our personnel, and take either suspension, alteration, or termination actions to avoid those high-risk situations. And then we want to monitor our people for physiological and physical stress to make sure that they are staying healthy while they perform the jobs. So the objectives, again, what we wanted to do is we wanted to identify the role of the HMSO during the implementation. We want to talk about that safety briefing and who does that and how to do that. We want to discuss the monitoring activities once we send people downrange. We want to make sure that you implement and enforce that site safety control plan that you work so hard to develop and integrate into the incident action plan. We need to make sure communications are considered and we have backups to communications, and identify how we take corrective actions, either suspend, alter, or terminate those events. Okay, activity 5.1. I'm going to call this if it's predictable. You know, Gordon Graham, for those of you who have watched any of his videos, one of his key things is if it's predictable, it's preventable. So what I want you to do is, this is going to be an individual written assignment. It's not paragraph long. This is a bullet item like assignment. I want you to look at your scenario and think about your scenario that you're sending people downrange to. And first of all, determine the work mission duration. Let's take that environmental information, the workload information, and so forth. Let's use that. Let's use that work mission duration chart and figure out what your work mission duration would be, and go ahead and list that. Then identify potential deviations or situations that might occur while that entry is happening that you could predict and be prepared for should they occur. I want you to list all of them that you can. Think about all of those potential deviations or situational changes that may be predictable, and list them, and list an action with them that you would take in order to either suspend, alter, or terminate that activity. So just a bullet item list of the potential deviations or situations that can occur. List each along with a action that you would take, and then go ahead and submit that online. That'll be activity 5.1. Later this week, we will post the termination activity. You already had an opportunity to read about incident termination in the previous unit. We'll repost that for you, and we're going to have you identify termination activities that would take place. So until the webinar next week, we look forward to talking to you if you need any help. Stay safe, and we will talk to you later.